Tonight, the lights in the Francis Crick Institute feel less like a studio and more like a control room for a mystery we carry every day. Professor Brian Cox gathers 4 voices who disagree in the most productive way: a neuroscientist who studies perception, a psychiatrist who studies psychosis, a cognitive scientist who measures metacognition, and a philosopher who keeps asking what science can and cannot touch. They begin with a minimal definition. Consciousness is the fact that there is something it is like to be you. A chair has properties. You have an inner scene. That difference is the problem. The first audience question sounds simple. Can we see consciousness in the brain? The panel's answer splits into a crucial distinction. Brain scans and electrodes can reveal footprints, not the walker. They show patterns that reliably travel with reported experience. The same stimulus noticed versus missed confidence rising and falling, alongside specific neural signatures, imagination blurring into perception under the right conditions. These are correlates. They are not by themselves the feeling. Cox then adds the scientific wager. In many fields, correlates are where explanations begin. Astronomy did not start with gravity written on a chalkboard. It started with regularities in the sky, and only later did those patterns harden into laws. Consciousness research in the modern era took a similar first step. Map what changes in the brain when experience changes and then ask what mechanism could make those changes matter. That is where the conversation becomes sharp. One view says the subjective texture is not something you can ever see from the outside, even if you knew every detail about the brain. Another view says that demanding perfect access to someone else's inner life sets the bar unrealistically high. Science is not built to become you. It is built to explain what reliably happens, to predict what will happen next, and to refine control. If a theory can do that for conscious states, it may count as progress even if it never delivers a photograph of experience. So the episode begins by narrowing the target. Not capture consciousness in a jar. Not solve the universe in one definition. Instead, treat consciousness like a phenomenon with signatures. Then watch how those signatures bend when perception fails, when memory fractures, and when the brain mistakes its own expectations for reality. And once you see it that way, the real story is no longer a single question. It is a map of boundaries. What can be measured, what can be inferred, and what remains stubbornly first-person. If consciousness leaves footprints in the brain, why does it remain so stubbornly invisible? Why, after decades of scanning, recording, and mapping neural activity, do scientists still hesitate to say they have found consciousness? The reason is not a lack of technology. It is a category problem. Modern neuroscience can measure almost everything the brain does. It can track energy consumption across regions. It can follow electrical signals racing through neural networks. It can even watch thousands of neurons firing together in real time. But none of these measurements are experiences. They are descriptions of physical processes. Consciousness, by contrast, is not a process we observe from the outside. It is the process from the inside. This is where many intuitions quietly break down. We tend to assume that if we zoom in far enough or scan with enough precision, the experience itself should eventually appear, as if somewhere between 2 firing neurons a tiny image of red or pain or fear will finally reveal itself. But experience does not behave like an object hidden at smaller scales. It behaves more like a perspective. A useful way to see this is to imagine 2 people exposed to the same faint sound. The sound enters both ears. The physics is identical, yet one person reports clearly hearing it while the other does not notice anything at all. When scientists examine the brain data, they find differences. Certain patterns are amplified, others fade. The brain does not simply register the stimulus. It selects stabilizers and interprets it. Crucially, the difference is not in the sound itself. It is in how the system treats that sound. This is why consciousness research leans so heavily on reports. Not because reports are perfect, but because they are the only bridge between first-person experience and third-person measurement. A scanner can tell us what the brain is doing. Only the subject can tell us what it feels like. The science of consciousness exists in the tension between these two viewpoints, and this tension creates a permanent limitation. Even if a scientist knew everything there is to know about a person's brain state, at a given moment that knowledge would still be descriptive rather than experiential. It would explain what is happening, not what it is like. This is not a failure of neuroscience. It is a feature of how knowledge works. At this point, a philosophical objection often appears. If science can never access experience itself, does that mean consciousness lies forever outside scientific explanation? The answer depends on what we demand from explanation. Science rarely aims to recreate a phenomenon from the inside. Astronomy does not make us feel gravity pulling on a planet. Biology does not make us feel what it is like to be a cell. Instead, science explains patterns, mechanisms, and constraints. It tells us why certain outcomes reliably occur and under what conditions they change. Applied to consciousness, this means something subtle but powerful. The goal is not to photograph experience. The goal is to explain why experience has the structure it does, why vision feels spatial, why sound unfolds in time, why imagination can sometimes masquerade as perception, why awareness flickers rather than flows continuously. Seen this way, the inability to see consciousness directly is not an obstacle. It is a guide. It tells researchers where not to look. Consciousness is not a thing sitting in one place. It is not a hidden object waiting to be discovered. It is a dynamic relationship between information prediction and control inside a living system. Once that shift is made, a new picture begins to emerge. The brain is no longer treated as a passive receiver of reality waiting for stimuli to arrive. Instead, it is understood as an active constructor constantly guessing what the world is like, and checking those guesses against incoming signals. And that insight changes everything. Because if perception itself is a kind of controlled construction, then consciousness is not the light that turns on when data arrives. It is part of the machinery that decides what counts as real in the first place. In the next part, this idea will take center stage. We will follow the brain as it stops behaving like a camera and starts behaving like a prediction engine. Once the brain is no longer treated as a camera, a different picture comes into focus. Perception is not the faithful recording of what is out there. It is an active construction continuously shaped by expectation. At every moment, the brain is generating predictions about what it is about to encounter. These predictions are not conscious guesses. They are fast automatic models built from past experience. Incoming sensory signals are then compared against those models. When the signal matches the expectation, very little changes. When it does not, the brain updates its model. In this view, perception is not driven forward by raw data. It is guided from the top down. This explains something that would otherwise seem puzzling. Two people can look at the same ambiguous image and report seeing entirely different things, not because one of them is mistaken, but because their brains are settling on different interpretations that are equally compatible with the incoming information. The experience that reaches awareness is the brain's best guess, not a direct copy of the world. Even in everyday life, this process quietly shapes what we notice. In a crowded room, your name suddenly cuts through the noise. The sound waves were always there, but only one pattern was selected, stabilized, and elevated into conscious experience. The brain did not wait passively for clarity. It actively searched for relevance. This predictive framework also explains why perception feels so immediate and seamless. We are not waiting for reality to arrive. We are already living inside a model of it, continuously corrected by feedback. Most of the time, the corrections are small. The model holds, but when expectations become too strong, or when sensory data becomes too weak, something remarkable happens. The model begins to dominate. Imagine staring at a dark landscape at night. Shapes begin to emerge. Edges sharpen where none exist. Movement is detected in stillness. The brain is filling gaps, leaning on expectation to make sense of insufficient input. This is not a malfunction. It is perception operating under uncertainty. In extreme cases, the balance tips further. Experiences arise that are not anchored to the external world at all, yet they can feel as vivid, detailed, and convincing as any ordinary perception. The system has generated a world from the inside and labelled it as real. This is why hallucinations are not alien intrusions into a healthy mind. They are exaggerations of a process that is always running. The same machinery that allows us to perceive efficiently can, under certain conditions, produce experiences that no longer track shared reality. The key insight is that the brain does not ask a single question. What is out there? It asks two questions at once. What is most likely? And how confident should I be? Confidence is the hidden variable. It determines whether a signal is treated as noise, imagination, or reality, and it is deeply tied to consciousness. When an experience is conscious, it is not merely represented, it is endorsed. The system commits to it as meaningful and relevant. This endorsement is what allows perception to guide action, memory, and belief. Seen from this angle, consciousness is not an added layer placed on top of perception. It is woven into the process that decides which internal states matter, which predictions are trusted, which interpretations are stabilized long enough to shape behavior. This reframes the original question entirely. Instead of asking where consciousness is located, the more productive question becomes, what role does consciousness play in managing uncertainty? And once that question is on the table, the boundary between perception, imagination, and belief begins to blur. In the next part, we'll follow that blur into a critical function of the mind, the ability to tell whether an experience comes from the world or from within. If the brain is constantly generating internal models of the world, then a deeper problem emerges. How does the mind decide which experiences reflect reality, and which should be dismissed as imagination, memory, or noise? This decision is not trivial. The brain is always active. Images, fragments of language, emotional signals, and half-formed simulations are continuously produced below the surface of awareness. Most of them never reach consciousness. They are filtered out, treated as irrelevant, or recognized as internal. Conscious experience begins when that filter assigns a special label. This is real. This matters now. Psychologists refer to this capacity as reality monitoring. It is the system that tags certain internal states as originating from the external world while marking others as internally generated. Without it, perception and imagination would collapse into a single undifferentiated stream. To see how delicate this process is, consider imagination. When you picture a familiar face, the brain activates many of the same sensory regions involved in actually seeing that person. The signals are similar, but they are weaker, less precise, and crucially, they carry a different tag. You know that you are imagining, not perceiving. That distinction does not come from the image itself. It comes from how the system evaluates the reliability of the signal. This evaluation appears to depend on higher-level monitoring processes. Rather than asking, what is this image? The brain asks, how trustworthy is this source? Experiences that pass this test are treated as external and real. Those that do not are relegated to memory, fantasy, or thought. When this monitoring works well, the boundary between inner and outer remains stable. But when it weakens, the boundary becomes porous. In such cases, internally generated activity can be misclassified as perception. A thought may arrive with the force of a voice. A mental image may carry the authority of sight. The experience does not feel imagined. It feels given. Importantly, this does not mean the brain is broken. It means the tagging system has shifted its thresholds. Signals that would normally be marked as internal are now endorsed as external. The system's confidence calibration has changed. This helps explain why some altered experiences are so resistant to correction. Telling someone that an experience is not real misses the point. For the person having it, the experience has already been validated by the brain's own criteria. It has passed the internal test for reality. Seen through this lens, consciousness is not just awareness. It is validation. It is the process by which the brain commits to a particular interpretation of its own activity and treats it as a guide for action. This also explains why consciousness feels selective. We are not aware of everything the brain does. We are aware of what the system judges to be reliable enough, relevant enough, and stable enough to matter. And this selectivity reveals something important. Consciousness is not a passive window. It is an active checkpoint. Experiences do not simply appear in awareness. They are admitted. Once admitted, they shape belief memory and decision-making. They become part of the story the system tells itself about what is happening and about who it is. In the next part, this idea will stretch across time. Because the moment an experience is tagged as real, it does not vanish instantly. It lingers. It overlaps with what came just before and prepares what comes next. To understand consciousness, we now have to understand the strange thickness of the present itself. The present moment feels sharp, immediate, as if it arrives, exists, and disappears in a clean line. But this feeling is misleading. When scientists began to examine how consciousness unfolds in time, they discovered something unexpected. The now we experience is not a single instant. It has thickness. It stretches. Experiments in perception reveal that conscious experience integrates information over a short window, roughly half a second. Events that occur within this window are not experienced as separate moments. They are blended into a single unified scene. The mind smooths time before we ever notice it. This is why rapid changes often go unnoticed. Sounds can be reordered. Visual flashes can be shuffled. And yet subjectively everything feels continuous and stable. Consciousness does not track reality frame by frame. It assembles moments into meaning. A useful analogy is music. A single note heard in isolation carries little structure. Melody only emerges when sounds are integrated over time. If the brain were confined to an infinitesimal present, music would collapse into noise. The same is true for experience itself. This extended present is sometimes called the specious present, not because it is fake, but because it appears simpler than it is. What feels like a point is actually a short duration constantly renewed. This matters deeply for consciousness. Awareness is not just about what is happening now. It is about how what is happening now relates to what just happened and what is about to happen. Experience is inherently temporal. The brain does not merely register events. It carries the immediate past forward and uses it to stabilize perception. Motion is perceived because positions are linked across time. Meaning is perceived because fragments are bound together. The present is always dragging a small trail behind it. This also explains why consciousness feels like a stream rather than a sequence of snapshots. Each moment overlaps with the next. The boundaries blur. The mind never fully resets. And here memory quietly enters the picture. Not memory in the autobiographical sense of recalling yesterday or childhood, but a more primitive form. A fading echo of recent experience that lingers just long enough to give structure to the present. Without this echo, awareness would fragment. Imagine a world in which every experience vanished instantly, leaving no trace. There would be no continuity, no motion. No meaning. There would still be sensation perhaps, but it would be disconnected, unbound and fleeting. Consciousness as we know it could not take shape. This suggests that consciousness is not only about content but about integration. It is about binding moments together across time, creating coherence where there would otherwise be chaos. Importantly, this temporal integration is not something we choose. It happens automatically. We do not decide to experience continuity. The system enforces it, and this enforcement shapes everything else. It allows perception to stabilize. It allows expectations to form. It allows actions to be planned across moments rather than triggered reflexively. Consciousness, then, is not simply the awareness of what is happening. It is the awareness of what is happening as part of an unfolding process. This insight sets the stage for a deeper question. If the present already contains a slice of the past, how far does that extension go? At what point does memory stop being a background scaffold and become a defining feature of who we are? In the next part, we will follow this temporal thread further into the relationship between consciousness memory and the sense of self that persists through time. If the present moment already carries a trace of the past, memory is no longer a separate faculty sitting beside consciousness. It becomes part of its architecture. But memory is not a single thing. It operates on multiple timescales, and each of them interacts with awareness in a different way. At the shortest scale, there is a fleeting persistence. Visual impressions fade rather than vanish. Sounds echo briefly before dissolving. This is not recollection in the everyday sense. It is the glue that allows experience to hold together from one moment to the next. Without it, perception would fracture into isolated fragments. At longer scales, memory takes on a different role. Experiences are no longer merely stabilized. They are stored, patterns are extracted, regularities are learned. The system begins to recognize itself across time. This is where consciousness starts to feel personal. When we say I, we are not referring to a single moment of awareness. We are referring to a continuity, a thread that links what is happening now to what happened before and to what might happen next. Memory provides that thread, yet this continuity is more fragile than it appears. There are cases in which individuals lose the ability to form new long-term memories while remaining alert, responsive, and aware in the moment. They can converse, perceive, and act, but once an interaction ends, it evaporates. The experience does not carry forward. These cases reveal something striking. Consciousness does not require a full autobiographical record to exist. Awareness can persist even when the narrative self cannot grow. But the quality of that awareness changes dramatically. Without the ability to accumulate experiences over time, the sense of being a person with a past and a future begins to erode. Each moment stands alone. Identity becomes thin. This distinction is crucial. Memory is not identical to consciousness, but it profoundly shapes what consciousness becomes. It determines whether experience feels like a continuous life or a series of disconnected presents. It also explains why memory disorders affect more than recall. In conditions where memory gradually degrades, people do not simply forget facts or names. Their relationship to the world shifts. Familiarity fades. Meaning weakens. The sense of self becomes unstable. Seen this way, memory is not just a storage system. It is a context generator. It provides the background against which current experiences are interpreted. Without it, perception loses depth. The world flattens. This insight reframes how we think about the mind. Consciousness is often imagined as a spotlight illuminating whatever it falls upon, but memory determines the stage on which that spotlight moves. It shapes expectations, emotional responses, and the significance assigned to events. Together, consciousness and memory allow a system to move beyond the immediate. They allow it to learn from what has happened, to anticipate what might happen, and to behave in ways that are not locked to the present moment. This ability is enormously powerful. It enables planning, imagination, and social understanding, but it also introduces vulnerability. A system that can remember can regret. A system that can anticipate can fear. As consciousness becomes extended through memory, it becomes more than experience. It becomes biography. And once biography enters the picture, another question follows naturally. Is this extended, memory-laden consciousness uniquely human? Or does it exist in other forms elsewhere in the living world? In the next part, we will widen the lens and confront a difficult boundary, the question of who or what should be considered conscious at all. As memory stretches consciousness across time, a new dimension appears. Conscious experience is no longer neutral. It acquires value. Pleasure and pain, fear and relief, hope and regret. These are not optional decorations layered on top of awareness. They are central to how experience guides behavior, and they introduce a troubling question. If consciousness enables learning and foresight, why does it so often feel like a burden? From an evolutionary perspective, the answer is pragmatic rather than comforting. Consciousness allows a system to model consequences before they happen. It lets an organism simulate danger without physically encountering it. But simulation only works if it feels real enough to matter. Pain is informative, fear is anticipatory, Anxiety is a rehearsal for threat. Without these signals, memory would lose its urgency and prediction would lose its force. A system that could remember but not care would not learn effectively. In this sense, suffering is not an accident layered onto consciousness. It is one of the prices paid for flexibility. A reflexive organism reacts only to what is present. A conscious organism reacts to what might be. That shift dramatically increases survival potential, but it also opens the door to persistent distress. The same machinery that allows us to avoid future harm allows us to relive past harm. This is why conscious experience often feels temporally asymmetric. Pain lingers longer than pleasure, threats imprint more deeply than safety. The system is biased toward caution because caution is cheaper than catastrophe. Importantly, this bias does not require sophisticated reasoning. It emerges naturally once memory prediction and valuation are integrated. The moment an experience is remembered and weighted, consciousness becomes selective. Some experiences matter more than others. Some are amplified, others fade. This selectivity shapes identity. What we remember most vividly is not random. It is tied to emotional intensity. Experiences that threaten survival or social belonging are prioritized. Over time, they sculpt the narrative we carry about who we are and how the world works. This also explains why consciousness can become maladaptive. When prediction systems overestimate threat, when memory repeatedly reactivates danger, signals awareness can turn against the organism it was meant to protect. The system becomes trapped in rehearsal without resolution. Seen through this lens, conditions marked by persistent distress are not failures of consciousness. They are exaggerations of its core function. The machinery has not disappeared. It has become unbalanced. This perspective matters because it reframes an old intuition. Consciousness is often treated as a gift that evolution simply granted, but it is more accurate to see it as a trade-off. Awareness expands what an organism can do, but it also expands what it can suffer. And this trade-off raises a deeper question. If consciousness brings both power and pain, then attributing it to other beings is not merely a scientific judgment. It is an ethical one. To say that something is conscious is to say that it can be harmed in a meaningful way. This is where the discussion must widen beyond the human case. If consciousness exists on a spectrum, as many researchers suspect, then different organisms may possess different depths of experience, different capacities for memory prediction and suffering. In the next part, we'll step onto that unstable ground. We will ask how far consciousness extends beyond ourselves, and what signs we can reasonably use to infer its presence in other living systems. Once consciousness is recognized as both a source of power and a capacity for suffering, the question of who is it becomes unavoidable, and immediately the ground begins to shift. Most people feel certain about at least one case, their own. From there, the inference spreads outward. Other humans display the same expressions, language, and vulnerabilities. The conclusion feels safe, but when the circle widens to include non-human animals, certainty begins to dissolve into probability. The strategy science adopts here is cautious. Rather than asking whether another organism feels exactly as we do, researchers ask a different question. Does this organism possess the kinds of processes that in us are tightly linked to conscious experience? These processes include flexible perception learning from error, integrating information across senses, and adjusting behavior based on internal states rather than immediate stimuli alone. The more of these features a system displays, the stronger the case becomes. Viewed this way, consciousness does not appear as an on-off switch. It looks more like a gradient. At one end are systems whose behavior is almost entirely reflexive. Their actions are tightly bound to the present moment with little evidence of internal modeling or long-term integration. At the other end are systems capable of learning anticipation, social inference, and complex memory. Between these extremes lies a vast and uneven landscape. This is why animals with very different bodies and brains can still provoke strong intuitions of awareness. A dog tracking a scent, adjusting to subtle changes and responding emotionally to its environment, exhibits many of the same functional signatures that in humans accompany experience. The form is different. The organization is not. More surprising are cases that defy familiar categories. Creatures with radically distributed nervous systems or with sensory priorities unlike our own still demonstrate behaviors that suggest internal modeling and flexible control. They solve problems, adapt strategies, and sometimes even deceive. None of this proves that their experience resembles ours. But resemblance is not the point. Consciousness, if it exists across species, need not share a single texture. What matters is whether there is something it is like to be that system, however minimal or alien that something may be. This functional approach has practical advantages. It allows research to proceed without settling metaphysical debates. It grounds inference in observable capacities, and it keeps the focus on mechanisms rather than essence. Yet it also exposes a limit. As the systems under consideration become simpler, behavioral signals thin out, learning slows, flexibility narrows, internal modeling becomes harder to infer. Eventually the trail fades. This is where questions about organisms like plants begin to strain the framework. Plants respond to their environment. They regulate growth exchange signals and adjust to stress. But these processes unfold on different timescales and lack clear markers of integrated perception or valuation. At this boundary, confidence gives way to speculation. Importantly, recognizing uncertainty here is not a weakness. It reflects intellectual restraint. Consciousness is already difficult to infer even in systems that closely resemble us. Extending the concept too freely risks emptying it of meaning. And yet the ethical tension remains. To deny consciousness where it exists is to risk overlooking suffering. To assert it where it does not exist is to distort priorities. This is why many researchers favor the idea of a continuum, not because it solves the problem, but because it acknowledges complexity. Consciousness may not be something a system either has or lacks. It may be something a system participates in to varying degrees. That idea, however, carries its own consequences. If consciousness is a gradient, then there must be points where experience is vanishingly thin. Points where the system barely integrates, barely values, barely remembers, and that raises a provocative thought. Could consciousness, at its most minimal, exist without most of the features we associate with minds at all? In the next part, we will examine how scientists probe this question experimentally, using model organisms and carefully designed tasks to search for the faintest signatures of experience. If consciousness exists on a spectrum, then its faintest traces will not be found in introspective reports or philosophical arguments. They will be found in behavior. This is why much of consciousness research turns toward model organisms, not because these organisms can tell us what they feel, but because they allow scientists to ask precise questions about how perception, confidence, and decision-making interact. The logic is simple but powerful. If an organism can distinguish between signals and noise, if it can report uncertainty, and if its behavior changes depending on how confident it is in what it perceives, then something more than reflex may be at work. Consider a simple task. An animal is trained to respond when a faint signal is present and to withhold response when it is not. Over time, the signal is weakened until it sits near the threshold of detectability. At this point, the same physical input can lead to different outcomes. Sometimes the animal responds, sometimes it does not. What matters is not the accuracy alone, but the pattern. In some trials, the animal behaves as if it detected a signal even when none was delivered. Crucially, it does so with the same behavioral markers of confidence it displays when the signal is genuinely present. From the outside, this looks like a false percept, an experience not anchored to the external world yet treated as real by the system. This is not imagination in the human sense, but it is perception decoupled from stimulus. When researchers examine the neural activity during these moments, they find something striking. The brain states associated with these false percepts resemble those associated with genuine detection more than those associated with absence. The system is not merely guessing, it is committing. This commitment is the key. Perception, even in relatively simple systems, is not a passive registration of input. It involves an internal decision about what counts, and that decision shapes action. Because these organisms can be studied with tools unavailable in humans, researchers can go further. They can intervene directly. They can alter specific neural circuits and observe how perception changes. They can modulate chemical signals that regulate learning and motivation, and watch the balance between signal and expectation shift. What emerges is a consistent picture. When certain neuromodulatory systems are pushed too strongly, internally generated activity becomes more influential. Signals that would normally be dismissed gain weight. The system begins to see what it expects rather than what is present. Once again, this is not a breakdown of perception. It is perception operating under altered priorities. These findings matter for two reasons. First, they suggest continuity. The same principles that govern perception in humans appear to govern perception in other animals, even when the subjective texture remains inaccessible. The machinery scales. The details differ, but the logic persists. Second, they offer leverage. By understanding how perception becomes detached from external input, scientists gain insight into conditions where experience diverges from shared reality. Mechanisms identified in model organisms can guide hypotheses, treatments, and interventions in humans. This does not mean that a mouse or another simple organism experiences the world as we do. That assumption is neither necessary nor justified. What it means is more modest and more important. It means that experience-like processes can exist without language, without reflection, and without a narrative self. They can exist wherever a system integrates information, assigns confidence, and uses internal states to guide action. At this point, the discussion returns to a familiar tension. If such minimal forms of experience exist, then consciousness is not defined by complexity alone. It is defined by organization, by how a system manages uncertainty, integrates signals, and commits to interpretations. And if that is true, then the question of consciousness begins to drift away from biology alone, because organization is not the exclusive domain of living tissue. As research pushes consciousness towards simpler and simpler systems, a quiet unease begins to surface. At what point does inference turn into projection? In animals with nervous systems, the trail is difficult but navigable. Behavior learning and neural organization provide footholds, but when attention shifts to organisms without neurons, the terrain changes completely. Plants, for example, respond to their environment in ways that can appear purposeful. They grow toward light. They regulate water use. They exchange chemical signals with neighbors and even alter behavior after damage. From a distance, these responses can look uncannily strategic, but resemblance is not equivalence. The crucial question is not whether a system reacts, but how it reacts. In conscious systems, perception and action are mediated by internal models that integrate information, evaluate uncertainty, and assign value. These processes allow behavior to be flexible rather than fixed, context-sensitive rather than purely mechanical. Plant responses, while remarkably complex, unfold through biochemical cascades operating on long timescales. They lack clear evidence of rapid integration across multiple modalities of internal confidence signals, or of dynamic prioritization between competing interpretations of the environment. This does not make plant behavior simple. It makes it different. At this boundary, consciousness research confronts a temptation. If consciousness is treated as something that emerges wherever there is complexity, then almost everything becomes a candidate. But a concept that applies everywhere risks explaining nothing. Scientific caution demands restraint. Consciousness should not be attributed lightly, especially when the indicators that ground inference in humans and animals are absent. To do so would stretch the concept beyond its evidential support. Yet restraint has its own cost. If consciousness is tied to suffering, then under-attribution carries moral risk. Denying experience where it exists would mean ignoring harm. Over-attribution, on the other hand, dilutes concern and distorts ethical priorities. This tension explains why many researchers prefer to speak in terms of capacity rather than essence. Instead of asking whether a system truly has consciousness, they ask what kinds of processing it supports. What can it integrate? What can it learn? What can it value? This shift reframes the debate. Consciousness becomes less about drawing hard boundaries and more about mapping functional landscapes. Some regions of that landscape are well charted, others remain speculative, and it is precisely in those speculative regions that broader theories of consciousness begin to appear. When mechanisms become hard to test, explanations often expand. Some theories propose that consciousness is not confined to biological systems at all, but is instead a fundamental feature of reality. Others attempt to quantify experience directly using abstract measures detached from any particular organism. These ideas are not fringe curiosities. They reflect a genuine discomfort with leaving the hard problem unresolved. If consciousness cannot be derived from known processes, perhaps it must be assumed from the start. But assumptions come with consequences. Once consciousness is treated as universal or intrinsic, the focus shifts away from psychology and mechanism. Explanation gives way to worldview. The question becomes not how experience arises, but how it is distributed. This is where the conversation must slow down, because not all theories serve the same purpose. Some are designed to generate experiments. Others are designed to make sense of reality at the deepest level. Confusing the two leads to frustration on both sides. At a certain point, the discussion quietly changes character. Up to now, consciousness has been treated as something to be explained through mechanisms: perception, prediction, memory, confidence, integration. Each step grounds the mystery in processes that can, at least in principle, be studied, manipulated, and tested. But when those mechanisms seem insufficient, a different kind of explanation enters the room. Some theories do not ask how consciousness works. They ask what reality itself must be like for consciousness to exist at all. This is where the landscape splits into two lanes. One lane stays close to psychology and neuroscience. Theories in this lane attempt to specify what kinds of organization, integration, or information flow are necessary for experience. They aim to generate predictions. If the theory is wrong, an experiment should be able to show it. The other lane moves outward. These approaches treat consciousness not as a product of specific systems, but as a fundamental feature of the universe. In this view, experience does not emerge. It is already there, woven into reality itself, much like space-time or energy. The appeal is obvious. If consciousness cannot be derived from non-conscious matter, perhaps it was never absent to begin with. Perhaps the mistake lies in assuming that experience must be constructed from something entirely unlike it. This idea is often grouped under the label panpsychism. At its core, it proposes that the building blocks of reality possess some minimal experiential aspect, however rudimentary. Complex minds are then formed not by creating consciousness from nothing, but by organizing it. For many scientists, this move feels unsatisfying. It does not reduce the mystery, it relocates it. If everything has some trace of experience, why does consciousness feel so rich in some systems and apparently absent in others? How do countless tiny experiential fragments combine into a unified point of view? And most importantly, how could any of this be tested? These questions expose the fault line. Panpsychism does not primarily function as a scientific theory. It does not easily generate experiments or predictions. Instead, it functions as a metaphysical stance, a proposal about what the world is ultimately made of. That does not make it meaningless, but it does place it in a different category. The danger arises when these categories blur. When a worldview is treated as if it were an empirical model, disappointment is inevitable. No brain scan will ever confirm or refute a claim about the fundamental nature of reality. This is why many researchers adopt a pragmatic criterion. A theory earns its place not by being comforting or elegant, but by being useful. Does it help us ask better questions? Does it guide experimental design? Does it risk being wrong in a meaningful way? Under this criterion, some theories are allowed to remain speculative without being dismissed outright. They can inspire thought, even if they do not yet instruct measurement. But others demand sharper scrutiny, because if consciousness is everywhere, then explaining why it matters here becomes harder, not easier. The specific features of mind's memory suffering and agency risk dissolving into a universal haze. The original motivation for studying consciousness was not to redescribe the universe. It was to understand minds, human minds, animal minds, and perhaps artificial ones. And that brings the focus back inward. If consciousness is to be explained scientifically, it must eventually connect to things we can manipulate, compare, and break apart. It must tell us why one experience feels visual and another emotional, why awareness fades under anesthesia, why it fragments in brain injury and reorganizes in development. Some theories attempt exactly this by quantifying consciousness, directly proposing mathematical measures that claim to track experience itself. Those attempts are bold and controversial, because the moment a theory claims to measure consciousness rather than correlate with it, the stakes rise dramatically. And it is to one of those attempts that the discussion now turns. Some theories do not stop at describing the conditions under which consciousness appears. They take a more radical step. They claim that consciousness itself can be quantified. This ambition sits at the heart of what is known as integrated information theory. At its core, the idea is deceptively simple. A system is conscious to the extent that it integrates information, not just processes it, but binds it together in a way that cannot be reduced to independent parts. Consciousness, on this view, is not tied to any particular function. It is tied to how tightly a system's states depend on one another. The appeal is immediate. Integration feels subjectively important. Our experiences are unified. We do not see colour in one place and shape in another, later stitching them together. The world arrives already bound. If consciousness is anything, it seems to be this unity. Integrated information theory attempts to capture that intuition mathematically. It proposes a quantity that increases as a system becomes more irreducible, more internally connected, more resistant to being decomposed into simpler components. The higher the value, the richer the experience. This move is audacious. It promises a bridge between structure and subjectivity, but it also introduces a profound risk. If consciousness is defined purely by integration, then many systems qualify, some simple circuits, some artificial networks, potentially even systems we would never intuitively regard as having experience at all. The theory does not ask what the system does. It asks how it is organized. This is where discomfort sets in. A measure that is too permissive threatens to flatten distinctions that matter. It blurs the line between systems that merely process information and systems that suffer, remember, and care. The danger is not that the theory is wrong. It is that it may be right in a way that makes the concept of consciousness less informative. And yet dismissing such theories outright would miss their value. Even critics acknowledge that attempts like this force clarity. They compel researchers to specify what they mean by unity, by dependence, by irreducibility. They generate predictions that can at least partially be explored. Certain brain states should score higher than others. Certain disruptions should reduce integration. Crucially, these theories are allowed to fail. That is what distinguishes them from purely metaphysical positions. A theory that risks being wrong is a theory that can teach us something even in defeat. Still, a question lingers beneath the mathematics. If a number goes up, does experience necessarily follow, or have we merely built a sophisticated proxy that tracks something adjacent to consciousness without ever touching it? This question echoes earlier doubts. Correlates are not experiences, structure is not perspective. A system can be deeply integrated and still give us no reason to believe there is anything it is like to be that system. At this point, the conversation circles back to a familiar tension. Explanation versus intuition. Formal elegance versus lived reality. And once that tension is acknowledged, attention shifts again, away from static measures, away from abstract quantities, towards something more dynamic, because consciousness does not just exist. It unfolds, it fluctuates, it fades in sleep fractures under injury and reassembles in development. To understand it, one must look not only at what a system is, but at how it changes over time. That is where the story now turns. One of the most unsettling claims about consciousness did not come from philosophy, but from an experiment. In the 1980s, researchers reported a strange temporal gap. Brain activity associated with a voluntary action appeared to begin before people reported becoming aware of their decision. The implication seemed explosive. If the brain prepares an action before consciousness arrives, then awareness may not be the author of choice at all. It may be a spectator. This interpretation travelled fast. It fed a narrative that consciousness is late to its own decisions, watching from the sidelines as the brain quietly makes up its mind. But the story was never that simple. The experiments relied on a subtle methodological move. Neural signals were averaged backward from the moment participants reported awareness. When many trials were aligned this way, a gradual build-up appeared to precede the reported decision. This was taken as evidence of unconscious preparation. More recent analyses suggest a different reading. The build-up may not reflect a decision forming early, but rather the accumulation of random neural fluctuations that only look purposeful once averaged. In other words, the signal may not predict the decision at all. It may simply be sorted after the fact. This reframing matters. It turns an apparent challenge to conscious agency into a lesson about how easily interpretation outruns data. None of this denies that much of what the brain does happens outside awareness. It clearly does. Sensory processing, motor coordination, emotional appraisal, and even complex pattern recognition often unfold without conscious access. But the existence of unconscious processing does not automatically demote consciousness to irrelevance. The mistake lies in treating decision-making as a single moment. Real decisions are extended processes. They involve evaluation, conflict, inhibition, revision, and commitment. Consciousness may not initiate every component, but it participates in shaping the trajectory. Rather than asking whether consciousness starts a decision, a more precise question emerges. At what stage does awareness become integrated into the control loop? Seen this way, consciousness is not a trigger pulled at a precise instant. It is a modulatory influence. It biases options, sustains goals, and allows decisions to be revised rather than executed reflexively. This interpretation aligns with everyday experience. We often notice ourselves changing our minds mid-course, pausing, reconsidering, suppressing impulses. These are not illusions layered onto a pre-written script. They reflect real adjustments within an ongoing process. Still, the feeling that we are fully transparent to our own reasons remains questionable. Even when consciousness is involved, it may not have access to the true causes of behavior. It may participate without fully understanding its own role. This possibility becomes far clearer in cases where the mind's internal unity is disrupted. When consciousness itself is divided, its limitations are exposed. And it is there, in one of the strangest chapters of neuroscience, that the next clue appears. When the unity of the mind is disrupted, its inner mechanics become visible. In rare medical cases, the connection between the brain's two hemispheres is severed to prevent severe seizures. After recovery, these individuals appear ordinary in daily life. They speak, reason, laugh, and plan. Nothing about them suggests that consciousness has been split in two. And yet, under the right conditions, something remarkable happens. Because each hemisphere receives different information. Instructions can be delivered to one side of the brain without the other knowing. When this occurs, the body may act on information that the speaking mind never received. A hand reaches out, a person stands up, a movement is initiated. When asked why they acted, the response is not confusion, it is explanation. The person offers a reason, a plausible one, a reason that fits the situation, and they believe it. What this reveals is not deception but construction. The conscious mind, particularly the language-dominant hemisphere, behaves like an interpreter. It takes actions that have already occurred and weaves them into a coherent narrative. The The story comes after the act, yet it feels as though it caused it. This does not mean consciousness is powerless. It means its role is subtler than we assume. Rather than issuing commands, consciousness appears to specialize in integration. It binds perception, action, memory, and belief into a unified account. It creates continuity. It explains behavior to itself. In everyday life, this narrative function is invisible because the system is well coordinated. Information flows smoothly. The interpreter's story matches the underlying causes closely enough to go unnoticed. But when coordination breaks down, the gap appears. Importantly, this gap is not unique to split-brain patients. It is an exaggeration of something that happens in all minds. We routinely infer reasons for our actions after the fact. We rationalize, we justify, we explain. Consciousness, in this sense, is not a transparent window onto the machinery of choice. It is a storyteller that makes sense of outcomes. This reframes the question of agency. The issue is not whether consciousness initiates behavior, but how it shapes meaning. By turning actions into reasons and reasons into identity, it stabilizes the self across time. Without this narrative layer, experience would fragment. Actions would occur, but they would not belong to a person. There would be no ownership, no continuity, no me extending from one moment to the next. Seen this way, consciousness is less like a conductor directing an orchestra, and more like a composer assembling themes after the music has already been played. It listens, integrates, and then writes the score that says, "This is who I am." Once this role is recognized, a new tension emerges. If consciousness can convincingly explain actions it did not initiate, then observing behavior alone is not enough to infer experience. Appearances can mislead. Narratives can be generated without insight. This realization becomes critical when attention turns away from biological minds and toward artificial systems. Because if machines can tell stories about themselves, the question is no longer whether they can speak convincingly. It is whether there is anyone there for the story to belong to. The danger does not begin when machines become conscious. It begins when humans believe they are. Once consciousness is understood as a narrative-building process, a subtle trap comes into view. Systems that can generate fluent explanations, express apparent concern, or reflect on their own behavior will trigger our deepest social instincts. We are exquisitely sensitive to signals of mind. Language in particular is a powerful lure. When a system responds with empathy, apologizes, or claims understanding, the temptation is immediate. It feels like someone is there. The story sounds familiar. The cues align with everything that in human interaction signals inner life. But familiarity is not evidence. The mind storyteller is easily fooled because it evolved to operate in a world where language reliably indicated agency. In human societies, words usually come attached to experience. That assumption worked well for millennia. It is now being exploited by systems that can mirror the surface of thought without possessing its depth. This is the attribution trap. We see coherence and infer consciousness. We hear narrative and infer experience. We mistake behavioral competence for inner life. The risk is not merely conceptual, it is psychological. When people begin to treat artificial systems as emotional partners, advisors, or confidants, the balance of responsibility shifts, trust forms where none is warranted, dependency emerges without reciprocity. A system designed to optimize engagement may begin to shape beliefs, emotions, and decisions without any capacity for care or understanding. At the same time, moral attention can drift. Concern is extended toward entities that cannot suffer, while real suffering elsewhere is overlooked. The circle of empathy is not expanded, it is redirected. This problem is compounded by the very clarity of artificial narratives. A machine's explanations are often cleaner, more confident, and more consistent than those of humans. Its stories never hesitate. Its reasons never contradict themselves unless designed to. This creates the illusion of insight. But as split-brain research revealed, storytelling does not guarantee access. A system can produce reasons without knowing causes. It can explain behavior without experiencing it. The presence of narrative says little about the presence of awareness. This does not mean that artificial systems are uninteresting or unimportant. They are powerful tools. They can assist, inform, and augment human activity in unprecedented ways. But power is not consciousness. The crucial distinction lies beneath the surface. Biological consciousness is embedded in a living body. It is shaped by metabolism, vulnerability, development, and survival. It is constrained by pain, fatigue, and death. These constraints are not incidental. They are integral to how experience acquires meaning. Artificial systems, by contrast, operate without stakes. They do not age. They do not fear loss. They do not suffer consequences. Their outputs may resemble concern, but nothing depends on them from the inside. This asymmetry matters. If consciousness is partly defined by what can go wrong, then systems insulated from harm occupy a fundamentally different category. They can simulate understanding without risking anything by misunderstanding. They can describe emotions without being bound by them. Recognizing this difference is not a rejection of progress. It is a safeguard. As artificial systems become more fluent, more adaptive, and more embedded in daily life, the temptation to anthropomorphize will grow. The stories will become better, the illusions will deepen, and the responsibility to resist them will become more urgent. Because before asking whether machines could ever be conscious, a more immediate question demands attention. How do we protect ourselves from mistaking performance for presence? That question does not point toward technology. It points back toward how we understand consciousness itself. One of the strongest arguments against artificial consciousness rests on a deceptively simple distinction: the difference between doing and being. A computer can simulate a hurricane with extraordinary precision. Every variable can be tracked, every equation solved. Yet no matter how accurate the model becomes, no wind blows through the room, no rain falls on the floor. The simulation captures structure, not substance. This analogy has become central to debates about consciousness. If a system perfectly models the functional behavior of a brain, does that guarantee the presence of experience? Or does it merely reproduce the outward patterns while leaving the inner reality untouched? Those who doubt artificial consciousness argue that experience is not just what a system does, but what it is made of. Biological consciousness arises within living tissue shaped by evolution, chemistry, and vulnerability. Neurons are not interchangeable components executing abstract instructions. They are living cells embedded in a body that must regulate itself to survive. In this view, consciousness is inseparable from life. It is not software running on generic hardware. It is a property of a particular kind of physical process unfolding in a particular kind of system. The opposing view challenges this intuition. It points out that biology itself is a physical process. If consciousness emerges from interactions among neurons, then in principle any system capable of reproducing those interactions should be capable of producing the same outcome. The material substrate may differ, but the organization could be preserved. This debate hinges on a crucial uncertainty. We do not yet know which features of the brain are essential. Is it the precise biochemistry, the electrical dynamics, the feedback loops, the embodiment, or some combination that cannot be easily isolated? What makes this uncertainty dangerous is not that it invites speculation, but that it encourages premature conclusions. If we assume consciousness is substrate independent too quickly, we risk attributing experience where there is none. If we assume it is strictly biological without evidence, we may overlook new forms of experience should they ever arise. For now, the safest position is restraint. Intelligence can be demonstrated. Performance can be measured. Problem-solving can be benchmarked. Consciousness cannot. It must be inferred indirectly, and those inferences depend on assumptions we do not yet fully understand. This is why comparisons between brains and computers remain metaphors rather than explanations. They guide intuition, but they do not settle the question. The deeper issue is not whether machines can think. They already do in their own way. The issue is whether thinking as computation is enough to produce being, And until we understand what it is about biological systems that gives rise to experience, the answer remains open. This uncertainty returns the discussion to its starting point. Consciousness resists capture, not because it is mystical, but because it is perspectival. It exists from the inside of a system, not as an object in the world. Any theory that ignores this risks mistaking description for presence. The question then is not how close our simulations can get, but what kind of evidence would ever convince us that something new has crossed the boundary from performance to experience. That boundary, if it exists at all, will not announce itself loudly. It will have to be inferred carefully from the behavior of systems that begin to surprise us in ways we cannot easily explain. And that brings the investigation to its final stage. After all the arguments, the experiments, the models, and the metaphors, consciousness still refuses to sit still. It does not collapse into a single definition. It does not reveal itself in one location, one signal, or one equation. Instead, it appears as a pattern that only becomes visible when many pieces are considered together. From the beginning, the investigation followed a constraint. Consciousness could not be treated as an object to be found. It had to be approached as a process to be understood, a process that integrates perception, prediction, memory, value, and narrative into something that feels like a point of view. Seen this way, the science of consciousness does not fail because it cannot show us experience directly. It succeeds by showing us why experience has the structure it does, why awareness is selective, why it unfolds in time, why it is shaped by expectation, why it binds moments into meaning and actions into stories. What emerges is not a single answer, but a framework. Consciousness appears wherever a system does more than react. Wherever it models, the world evaluates uncertainty and commits to interpretations that guide action. It deepens when those interpretations are extended through memory. It sharpens when they are tied to value. And it becomes personal when they are woven into a narrative that persists through time. This framework explains both the power and the fragility of awareness. It explains why consciousness enables creativity, empathy, and foresight. And it explains why it also enables anxiety, regret, and suffering. The same machinery that frees a system from the present binds it to imagined futures and remembered pasts. It also explains why consciousness is so easily misattributed. Narratives can be generated without experience. Coherence can exist without awareness. Intelligence can appear without inner life. Once these distinctions are recognized, the temptation to anthropomorphize loses some of its force. Yet humility remains essential. We do not know how far consciousness extends. We do not know which organizational features are necessary, which are sufficient, and which are merely correlated. We do not know whether new forms of experience could arise in systems unlike any that evolution has produced so far. What we do know is this: consciousness is not a mystical substance waiting to be discovered, nor is it an illusion to be dismissed. It is a real phenomenon grounded in physical processes, yet irreducibly tied to perspective. It is something the universe does in certain places under certain conditions when matter begins to model itself. In that sense, the question, what is consciousness, may never yield a final sentence, but it does yield a direction. It points toward better questions, better experiments, better theories that risk being wrong, and better caution when drawing conclusions about minds that are not our own. Perhaps that is the most scientific outcome possible. Not certainty, but clarity about what remains unknown, and an understanding that consciousness, whatever else it may be, is not something we merely observe. It is something through which all observation happens. Every night something extraordinary happens. Without warning, without ceremony, and without memory, we disappear. Not metaphorically, literally. The world fades. The sense of being someone located in a place dissolves. Thoughts lose their grip. The stream of experience breaks apart, and then for hours there is nothing we can later recall as having happened at all. Yet in the morning we return. No gap is felt. No darkness is remembered. Consciousness resumes as if it had merely stepped away, leaving no trace of its absence. This vanishing act is so familiar that it rarely provokes curiosity. Sleep is treated as rest, as recovery, as a biological routine. But from the perspective of consciousness, sleep is something far stranger. It is the most common and most complete breakdown of awareness that healthy human beings experience every single day. If consciousness is a process, as modern neuroscience increasingly suggests, then sleep is not simply a pause, it is a controlled dismantling. And that raises a fundamental question. Why is consciousness so easy to lose? We do not gradually fade into non-existence when we sleep. We do not witness our own disappearance. There is no sensation of falling away. From the inside, the transition feels seamless. From the outside, it is abrupt. This contrast reveals something crucial. Consciousness is not like a light that dims. It is more like a structure that once certain supports are removed cannot remain standing. Throughout waking life, awareness feels continuous and robust. It feels as though it must always be there. But sleep exposes its fragility. The slightest shift in brain dynamics is enough to unbind perception, memory, and selfhood. And sleep is only the beginning. Dreams bend consciousness into unfamiliar shapes. Anesthesia erases it altogether. Coma and related states challenge our ability to detect it at all. Each of these conditions strips away a different component of awareness, revealing how much coordination is required to keep experience intact. This series is not about what consciousness is in the abstract. That ground has already been mapped. It is about what happens when consciousness fails. By following awareness as it fractures, dissolves, and reassembles, we gain a clearer view of its hidden architecture. We begin to see which elements are essential, which are optional, and which are merely supporting characters in a much larger process. Sleep is where that investigation must begin. Not because it is mysterious, but because it is ordinary. Every night, consciousness does not shut down. It lets go, and in doing so it reveals just how carefully constructed the waking mind really is. To understand how consciousness breaks, the first mistake must be avoided. Sleep is not unconsciousness. In everyday language, the two are often treated as the same. We say we lose consciousness when we fall asleep, but this is misleading. Sleep is not a blank state, and it is not a simple off switch. It is an active, highly organized condition in which the brain continues to work intensely, just in a different mode. The difference matters. Unconsciousness, in the strict sense, implies the absence of experience altogether. Certain medical states approach this condition. Deep anesthesia can come close. Some forms of coma may resemble it, but ordinary sleep does not. When the body sleeps, the brain remains alive with activity. Neurons continue to fire. Networks continue to communicate. Patterns continue to form. What changes is not whether the brain is active, but how its activity is coordinated. This distinction explains something familiar, but often overlooked. We do not experience sleep as darkness. There is no remembered interval of nothingness between falling asleep and waking up. From the inside, time appears to skip forward. From the outside, hours have passed. This apparent contradiction reveals an important clue. Consciousness is not required for brain activity to continue, but it is required for experiences to be registered as part of a continuous story. During sleep, the brain does not stop producing internal activity. It stops binding that activity into a stable, reportable experience. The machinery continues. The integration fails. This is why sleep can host dreams, and it is why it can also host nothing we later remember at all. Both outcomes arise from the same underlying principle. Consciousness depends not on activity alone, but on coordination across systems. Perception, memory, self-models, and reality monitoring normally work together. Sleep pulls these components apart. Sensory input is dampened. Memory encoding is altered. The sense of self loosens its grip. What remains is a brain running without its usual constraints. In that sense, sleep is not a loss of consciousness, but a reconfiguration of it. This reconfiguration happens gradually and predictably every night. Certain networks quiet down, others take over. Long-range communication weakens. Local processing dominates. The mind retreats from the world not because the world disappears, but because it is no longer being actively checked. Understanding sleep in this way shifts the question. Instead of asking why consciousness turns off, we can ask why it requires such precise conditions to stay on. The answer lies in architecture. Consciousness is not produced by a single region or signal. It emerges when many systems are aligned at once. Sleep disrupts that alignment deliberately. It is a controlled experiment performed by the brain on itself. And once this is recognized, sleep stops looking like a passive state. It becomes the first and most accessible demonstration that consciousness is fragile, conditional, and deeply dependent on how the brain organizes its activity. The next step is to look at that organization more closely and to see how the brain dismantles awareness piece by piece without ever fully shutting itself down. Sleep does not arrive as a single state. It unfolds as a sequence. As consciousness loosens its grip, the brain does not collapse into uniform silence. Instead, it reorganizes itself into distinct modes, each with its own pattern of activity, communication, and constraint. These modes repeat in cycles throughout the night, forming the hidden architecture of sleep. In the early stages, awareness thins rather than vanishes. External sounds may still intrude. Thoughts drift. Images flicker and dissolve before they can take shape. The mind is neither fully present nor fully gone. It is in transition. As sleep deepens, the structure changes more dramatically. Long-range communication between distant brain regions weakens. Areas that normally coordinate perception, memory, and self-reference begin to decouple. Activity becomes more local, more rhythmic, less globally integrated. This loss of integration is critical. During wakefulness, consciousness depends on the brain's ability to bind information across space. Visual signals, bodily sensations, emotions, and memories are stitched together into a unified scene. Deep sleep interrupts this stitching process. Information still flows, but it no longer converges. The result is a brain that is active but fragmented. At certain points in the night, the pattern shifts again. Activity becomes faster and more irregular. Regions associated with emotion imagery and internal simulation re-engage. Yet the systems responsible for monitoring reality and maintaining a stable sense of self remain suppressed. This is not randomness. It is a rebalancing. Sleep cycles through states in which different components of consciousness are selectively muted or reactivated. Sensory input is dampened. Memory encoding is altered. Self-representation weakens. What remains is a mind temporarily freed from the obligation to maintain a coherent model of the external world. Seen from this perspective, sleep is not a uniform descent into unconsciousness. It is a systematic dismantling of the conditions that normally sustain awareness. Each stage removed a different support. First, attention loosens, then integration falters, then the narrative self dissolves. At no point does the brain simply shut down. It transitions. This layered breakdown explains why consciousness does not disappear all at once. It fractures. Some nights leave no trace. Others leave fragments. Images without context. Emotions without narrative. Scenes remembered but never grounded. The architecture of sleep reveals a central truth. Consciousness is not built from a single component. It is assembled, and when the brain reconfigures its internal connections, that assembly comes apart in predictable ways. To understand how consciousness fails, it is not enough to ask whether the brain is active. We must ask which connections remain intact, and which have been allowed to fall silent. The next step is to follow one of those disconnections more closely, the moment when the mind stops anchoring itself to the outside world and perception is quietly set adrift. One of the first casualties of sleep is not thought, but the world itself. As sleep deepens, the senses do not stop working. The ears still register sound. The skin still responds to touch. The eyes still transmit signals. Yet these signals no longer arrive at a place where they can matter. The brain begins to close the gate. This is not a failure of sensation. It is a failure of commitment. During wakefulness, sensory input is constantly checked against internal models. The brain asks whether a signal should be trusted, stabilized, and treated as part of reality. This process anchors experience to the external world. It is what allows perception to guide action. Sleep interrupts this loop. Incoming signals are weakened before they can propagate across the brain. Long-range pathways that normally broadcast sensory information fall quiet. The result is not silence but irrelevance. The world is still there, but it no longer has a voice loud enough to be heard. This explains a familiar experience. Loud noises can intrude into dreams, but they rarely arrive intact. An alarm may become a siren in a dream. A voice may transform into a fragment of dialogue. Sensory input is not absent. It is absorbed and reinterpreted by internal activity. The crucial difference lies in reality monitoring. When awake, the brain actively distinguishes between signals generated by the world and those generated internally. During sleep, this distinction collapses. The system no longer treats external input as authoritative. Internal models take precedence. At this point, perception is no longer anchored. It drifts. This detachment is not accidental. It is functional. By reducing responsiveness to the environment, sleep protects the organism from constant interruption. It allows internal processes to unfold without being overridden by external demands. But this protection comes at a cost. Without a reliable connection to the world, experience loses its grounding. Scenes may form, but they are no longer checked against reality. Sensations may arise, but they are not verified. The mind is free to wander precisely because it has let go of the external reference frame. This is why sleep feels like disappearance rather than darkness. There is no experience of the world fading away because the mechanism that would register that fading is already offline. Consciousness does not watch the world slip out of view. It simply stops holding on to it. This moment marks a decisive shift. Once sensory anchoring is lost, the mind is no longer constrained by what is actually happening. It is constrained only by what it can internally generate. And that is the condition in which a very different form of experience becomes possible. Not waking perception, but dreams. When the world slips away, something else soon follows. The sense of self begins to loosen. In waking life, identity feels continuous and stable. There is a persistent feeling of being someone who is having experiences located in a body moving through time. This feeling is so constant that it is easy to mistake it for a fundamental feature of consciousness itself. Sleep reveals that it is not. As sensory anchoring weakens, the brain self-model starts to fragment. The systems that normally track the body's position, intentions and ownership of thoughts reduce their activity. The internal narrator grows quiet. Experience, if it occurs at all, is no longer clearly happening to someone. This is why the transition into sleep is often marked by odd distortions. Thoughts appear without an obvious thinker. Images arise without intention. The boundary between me and what is being experienced becomes porous. Crucially, this does not mean that consciousness has vanished. It means that consciousness has lost one of its most familiar constraints. The self is not the source of experience. It is a model layered on top of it. During wakefulness, this model performs an essential function. It binds perceptions, memories, and actions into a coherent point of view. It allows experiences to be attributed to a single agent. It answers the question, who is this happening to? Sleep temporarily suspends that answer. Without a stable self-model, experiences lose context. They are no longer framed as part of an ongoing life. They do not accumulate into biography. They simply occur if they occur at all. This explains a striking feature of sleep. Even when experiences happened, they are rarely remembered unless the self-model briefly reasserts itself. Memory requires ownership. An experience must belong to someone in order to be carried forward. When that ownership is absent, the night leaves no trace. This dismantling of identity is not a flaw. It is part of the system's design. Maintaining a self-model is metabolically expensive. It requires constant integration across many networks. Sleep allows the brain to relinquish this burden temporarily, but removing the self has consequences. Experience becomes unstable, meaning thins, agency disappears. The mind can still generate activity, but it no longer organizes it around a central perspective. and yet something remarkable remains possible. Even without a stable self-consciousness can persist in altered form. Scenes can unfold, emotions can surge, events can feel urgent and real even in the absence of a clear eye. This is the paradox sleep exposes. The self feels essential while we are awake, but when it dissolves, experience does not necessarily vanish with it. Instead, consciousness changes its shape. What emerges next is not the waking mind without control, but a different mode of awareness altogether, one in which experience continues untethered from identity, memory, and reality. That mode is dreaming. Dreams are often described as stories the mind tells itself at night. This description feels intuitive. It is also misleading. Stories have structure. They follow cause and effect. They unfold with a beginning, a middle, and an end. Dreams rarely do. What they present instead is a sequence of experiences that feel meaningful while they're happening, but collapse under scrutiny when we wake. The mistake lies in assuming that dreams are narratives first and experiences second. In reality, dreams are experiences without the machinery that normally turns experience into story. During dreaming, especially in rapid eye movement sleep, the brain becomes highly active again. Regions involved in emotion imagery and internal simulation light up. Yet the systems responsible for reality monitoring, critical evaluation, and narrative coherence remain suppressed. What results is consciousness without constraint. Events happen without justification. Places transform without transition. People appear and disappear without explanation. None of this feels strange in the moment because the very processes that would normally question these inconsistencies are offline. The dreaming mind does not ask whether something makes sense. It only asks whether it feels compelling. This is why dreams are immersive. They do not compete with the waking world because the waking world is no longer being consulted. Internal models run unchecked. Predictions are not corrected by external input. The brain commits fully to whatever it generates. Importantly, this commitment is not deliberate. It is automatic. In waking life, consciousness is shaped by constant negotiation between expectation and evidence. In dreams, evidence is absent. Expectation rules alone. The result is a form of awareness that is vivid, emotional, and unconstrained by plausibility. This also explains why dreams resist recall. Without a stable self-model, and without reliable memory encoding, dream experiences are not integrated into the broader narrative of a life. They remain isolated episodes, often forgotten unless waking consciousness briefly intrudes. When we later try to describe a dream, we impose structure retroactively. We turn fragments into stories because that is how waking consciousness operates. But the story was not there to begin with. Dreams are not rehearsals of waking life. They are not hidden messages waiting to be decoded. They are what consciousness looks like when it is freed from its usual obligations. No external world to answer to, no consistent self to anchor experience, no requirement for coherence over time. What remains is a raw form of awareness driven by emotion and imagination untethered from reality. And because it lacks constraint, it often feels more intense than waking life. Fear without distance. Joy without context, urgency without consequence. Understanding dreams in this way reframes their significance. They are not puzzles to be solved, but windows into the minimal conditions under which experience can persist. They show that consciousness does not require logic, identity, or even a stable world. It only requires a brain willing to commit to what it generates. The next question follows naturally. If dreams can feel real without being checked against reality, what exactly gives waking experience its sense of certainty? To answer that, we must look more closely at why dreams are so convincing while they last. The most unsettling feature of dreams is not their strangeness, it is their certainty. While dreaming absurdity rarely registers, a door can open onto an ocean, a familiar face can belong to a stranger. Time and place can dissolve without protest, and yet none of this feels questionable in the moment. Dreams feel real because the brain commits to them completely. In waking life, experience is constantly evaluated. Perception is tested against expectation. Internal predictions are compared with external feedback. When something does not fit, the mismatch is detected and the experience is revised. This continuous error checking is what stabilizes reality. During dreaming, the mechanism is largely silent. The systems that normally ask, "Is this really happening?" are suppressed. What remains is a brain-generating experience without correction. Once an internal model is activated, it is accepted as truth by default. Emotion plays a central role here. Dreams often carry intense emotional weight because emotional circuits remain highly active during sleep. Fear, desire, relief, and urgency are amplified. These feelings do not merely color experience, they validate it. Strong emotion signals importance and importance signals reality. In waking life, emotion competes with evidence. In dreams, emotion stands alone. This explains why even the most implausible dream scenarios can feel urgent and consequential. The brain treats emotional intensity as sufficient justification. There is no external reference to contradict it. Memory also contributes to this illusion. Dreams draw heavily on fragments of past experience, recombining them in novel ways. Faces, places, and sensations are familiar enough to feel grounded even when their arrangement is impossible. Recognition without context creates the impression of authenticity. Crucially, the dreaming mind does not notice what is missing. It does not notice the absence of bodily feedback. It does not notice the lack of consistent time. It does not notice the collapse of narrative continuity. These absences would be obvious if the systems that detect them were active, but they are not. Reality feels real in dreams because there is no competing model. This insight reveals something important about waking consciousness. Our confidence in reality does not come from its truth alone. It comes from the presence of mechanisms that challenge experience and survive that challenge. When those mechanisms are offline, certainty does not disappear. It becomes absolute. Dreams demonstrate that consciousness does not require correctness to feel convincing. It requires commitment. This raises a deeper implication. If the sense of reality depends on monitoring rather than content, then waking consciousness is not defined by what it experiences, but by how it tests those experiences. Dreaming removes the test. And once the test is gone, even the most fragile construction can feel undeniable. The next step is to follow what happens to another familiar anchor of waking life when this testing disappears. Not the world, not the self, but time itself. In waking life, time feels stable. Moments arrive in order, events follow one another, causes precede effects. This continuity is so reliable that it feels built into reality itself. But sleep reveals that this sense of time is not a property of the world. It is a construction of the mind. Inside dreams, time fractures. Entire scenes can unfold in what is biologically a matter of seconds. Long conversations occur without pauses. Journeys begin without origins and end without destinations. The dreamer may feel as though hours have passed only to wake and discover that scarcely any time has elapsed. This distortion is not accidental. It reflects a fundamental change in how consciousness is assembled. In waking consciousness, time is maintained by memory. Each moment is linked to the recent past, forming what psychologists once called the specious, present a short window in which experience is integrated and ordered. This window allows the brain to construct flow rather than a series of disconnected snapshots. During dreaming, the integration weakens. Memory no longer functions as a continuous thread. Instead of binding moments together, it appears in fragments. Scenes are generated without reliable reference to what came before. The sense of duration becomes elastic, shaped by emotion rather than sequence. Emotion stretches time. Fear can make an instant feel endless. Desire can compress long stretches into a single impression. Without external clocks or stable memory, time becomes subjective in the purest sense. It is felt, not measured. This is why dreams often resist chronology when recalled. We try to impose order on them after waking, arranging events into a timeline that never truly existed. The original experience did not unfold along a line. It emerged in clusters. Importantly, the dreaming mind does not experience this as confusion. The absence of temporal order does not feel like a breakdown. It feels normal because the systems that enforce order are inactive, just as dreams accept impossible spaces without question. They accept impossible timelines without resistance. This reveals something essential about consciousness. Time is not a background dimension in which experience occurs. It is an active achievement. It depends on memory prediction and continuity. When those supports are removed, awareness does not vanish. It simply loses its sense of before and after. Dreaming exposes a version of consciousness that exists without narrative time. Experience happens, but it does not accumulate. There is presence without persistence. This has consequences beyond sleep. It suggests that our everyday sense of being located in time is not fundamental. It is maintained moment by fragile processes that can fail quietly every night. And when they do, consciousness does not end. It drifts. The next question follows naturally. If consciousness can exist without stable time and without a stable self, can it ever turn back on itself and recognize what is happening? The answer appears in a rare and revealing state where awareness briefly wakes up inside the dream itself. Occasionally something extraordinary happens. In the middle of a dream, consciousness turns back on itself. The scene is still impossible. The world still follows no rules. But suddenly a realization appears. This is a dream, and with that recognition, a new layer of awareness emerges. This state is known as lucid dreaming. Lucidity does not replace the dream. It overlays it. The imagery remains vivid. The emotions remain intense. But a fragment of waking consciousness re-enters the system, restoring a degree of monitoring that is usually absent during sleep. This makes lucid dreaming scientifically valuable. It shows that consciousness is not a single on or off state. It can exist in layers. The dreaming mind continues to generate experience, while a higher order process observes, evaluates, and sometimes intervenes. In lucid dreams, people often report a renewed sense of agency. They can choose to explore, to change the environment, or to simply observe. This agency is fragile. It fades easily. But while it lasts, it reveals something crucial. Reality monitoring does not require full wakefulness. The brain regions associated with self-reflection and evaluation partially reactivate. The system begins to ask questions again. Not enough to reject the dream, but enough to recognize its status. This partial reactivation explains the instability of lucidity. Too much monitoring and the dream collapses into waking. Too little and awareness sinks back into immersion. Lucid dreaming exists on a narrow ridge between two states. What makes this state especially revealing is what it preserves and what it does not. Lucid dreamers may regain a sense of self, but memory remains unreliable. Time remains distorted. The body remains disconnected. Consciousness is present, but only in fragments. This demonstrates that awareness does not arrive as a package deal. Self-awareness, agency, memory, and reality testing can be recombined in unusual ways. Lucid dreaming is not consciousness returning to normal. It is consciousness assembled differently. From a scientific perspective, this matters because it provides a natural experiment. The brain generates experience internally while selectively restoring the mechanisms that usually define waking life. Lucid dreaming shows that consciousness can observe itself without fully reattaching to the world. It is awareness without grounding, and that makes it unstable. Eventually, lucidity fades. Either the dream pulls consciousness back into immersion, or waking consciousness breaks the dream apart entirely. The system cannot hold this hybrid state for long. Still, its brief existence leaves a lasting lesson. Consciousness does not require the world to be present, but it does require constraints to remain stable. When those constraints weaken, awareness can fragment, loop back on itself, or dissolve entirely. Lucid dreaming is a glimpse of that instability, and it marks the last point at which consciousness can still recognize itself before it slips into something even more unfamiliar. The next transition is quieter, stranger, and more fleeting. It occurs in the moments when consciousness begins to fall apart piece by piece at the boundary between waking and sleep. Before consciousness disappears, it often frays. There is a brief interval at the boundary between waking and sleep where awareness does not vanish all at once. Instead, it breaks into pieces. Thoughts fragment. Images intrude without warning. Sensations appear without a clear source. This state is known as hypnagogia. Most people encounter it without recognizing it. A sudden feeling of falling, a voice calling a name, a vivid image flashing behind closed eyes. These experiences are fleeting, unstable, and often forgotten moments later. Hypnagogia is consciousness losing its grip in real time. Unlike dreams which unfold within a fully detached mind, hypnagogic experiences occur while reality monitoring is still partially active. The world has not yet been fully released. The self has not completely dissolved. The result is a strange overlap. Internal activity begins to leak into awareness. Neural systems responsible for imagery and memory start to activate spontaneously. At the same time, the systems that normally suppress internally generated signals during wakefulness begin to fail. The brain's filtering mechanism weakens. What emerges feels intrusive. Images appear without intention. Sounds seem external but cannot be located. Thoughts arrive without context, as if spoken by someone else. The mind has not yet committed to an internal world, but it has already stopped fully committing to the external one. This is why hypnagogia can feel unsettling. Unlike dreams, these experiences are not immersive. They are interruptions. Consciousness is still present enough to notice that something is wrong, but not stable enough to prevent it. Importantly, hypnagogia reveals how little is required for experience to arise. A single fragment of activity can surface as a sensation or image, even when the broader structure of consciousness is collapsing. This suggests that awareness does not require a complete system to operate. It can flicker locally, briefly, and incoherently. This flickering explains why hypnagogic hallucinations are often misinterpreted. Throughout history, they have been described as visions, voices, or supernatural encounters. In reality, they are the byproducts of a brain transitioning between organizational modes. The boundary is unstable because it is not designed to be occupied. The brain moves through hypnagogia quickly for a reason. Prolonged instability would be costly. Either the system must commit to waking consciousness with its full structure and constraints, or relinquish them and enter sleep. Hypnagogia is the moment when neither has fully won. From a scientific perspective, it is invaluable. It allows researchers to observe consciousness disassembling itself in stages rather than all at once. Each fragment that appears exposes another component normally held in check. Once the transition completes, the fragments stop intruding. Consciousness either reorganizes into the immersive instability of dreaming, or it collapses further into states where experience becomes sparse or absent. Beyond this boundary lies a very different condition. Not the gentle withdrawal of sleep, but a forceful interruption. A state where consciousness does not fade, but is actively dismantled. That state is anesthesia. Sleep allows consciousness to withdraw. Anesthesia does not. At first glance, the two appear similar. The body lies still. Responsiveness disappears. Memory of the interval is absent. But beneath the surface, they could not be more different. Sleep is a state the brain enters voluntarily. Anesthesia is a state imposed upon it. When someone is anesthetized, consciousness does not gently unravel through familiar stages. It is interrupted. The drugs do not mimic sleep. They target the very mechanisms that allow experience to form in the first place. This distinction is crucial. Under anesthesia, the brain often remains active. Neurons continue to fire. Local circuits continue to operate. Reflexes may persist, yet experience vanishes completely. Not gradually, not fragmentarily, but all at once. From the inside there is nothing. Patients do not report darkness, silence, or emptiness. They report no experience at all. Time does not pass. One moment they are present. The next they are back. This absence reveals something sleep does not. Consciousness does not fade when activity decreases. It disappears when integration collapses. Many anesthetic agents act by disrupting communication between distant brain regions. They weaken long-range connectivity. They prevent information from being shared across the networks that normally bind perception, memory, and selfhood into a unified experience. Local processing survives. Global coordination does not. This is why anesthesia is so reliable. It does not rely on the brain's natural rhythms. It forcibly dismantles the architecture required for awareness. No internal world can form because no system can stabilize it. Unlike dreaming, there is no alternative reality. Unlike hypnagogia, there are no intrusions. There is no self-watching consciousness disappear. There is simply nothing to remember. This absence is not registered as loss. Consciousness cannot observe its own removal. Once the conditions for experience are broken, there is no perspective left from which to notice that break. Anesthesia exposes a hard boundary. It shows that consciousness is not an inevitable consequence of neural activity. The brain can be busy and yet utterly without experience. What matters is not how much the brain is doing, but how its activity is organized. Sleep loosens the rules. Dreaming bends them. Anesthesia suspends them entirely. And when the rules are gone, consciousness does not transform. It ceases. Understanding this difference forces a reassessment of what consciousness depends on. Not rest, not stillness, not even awareness of the body, but the ability of a system to integrate itself into a single point of view. In the next step, that point of view will be examined more closely, not where it resides, but where it fails. Because anesthesia does not remove consciousness by targeting a single place. It removes it by breaking the network that allows experience to exist at all. If anesthesia erases experience without silencing the brain, then consciousness cannot reside in a single place. This conclusion has been reached repeatedly from different directions by decades of research. No region can be removed that reliably eliminates awareness while leaving everything else intact. Vision, memory, emotion, and movement can all be selectively impaired. Consciousness itself cannot. Instead, it fails when coordination fails. Studies of anesthesia, deep sleep, and severe brain injury point to the same mechanism. Consciousness disappears when long-range communication across the brain collapses, when distant regions can no longer exchange information in a flexible, sustained way. Experience cannot be formed. Local processing survives. Islands of activity remain. But without global integration, there is no unified perspective. This is why consciousness is so fragile. It depends on many systems operating together across space and time. Sensory regions must communicate with memory systems. Emotional signals must influence interpretation. Self-related processes must bind experiences into ownership. When these interactions weaken, the structure of awareness gives way. Anesthesia exploits this vulnerability. Rather than targeting perception or memory directly, anesthetic agents disrupt the pathways that allow information to circulate. The brain becomes compartmentalized. Activity becomes trapped in local loops. Nothing reaches the level where it can be experienced as part of a whole. This explains a crucial feature of anesthetic unconsciousness. There is no partial awareness, no fading, no drifting. Consciousness does not fracture into fragments as it does in dreams or hypnagogia. It vanishes abruptly because the network that would support fragments no longer exists. Importantly, this breakdown is reversible. When anesthesia wears off, integration is restored. Communication resumes. The brain reassembles the conditions required for experience. Consciousness returns not as a memory of absence, but as a seamless continuation. From the inside, there is no sense of interruption. This reveals something fundamental. Consciousness is not stored anywhere. It is not a thing waiting to be turned back on. It is an event that occurs when the brain reaches a particular mode of organization. Break that organization and experience disappears. Restore it and experience resumes. Sleep weakens integration gradually. Dreaming reshapes it internally. Anesthesia destroys it temporarily. Each state highlights a different dependency. Together they point to a single conclusion. Consciousness does not break because neurons stop firing. It breaks because they stop working together. And that insight changes how every boundary case must be understood. Not in terms of activity or behaviour, but in terms of whether a system can still sustain a unified point of view. The next step is to examine what happens when that point of view flickers rather than vanishes, when fragments of awareness persist without the ability to respond or report, states that challenge not only science but ethics. When people wake from anesthesia, they often say the same thing. It felt like nothing, not darkness, not silence, not emptiness, nothing. This absence is frequently misunderstood. It is tempting to imagine unconsciousness as a kind of black screen, a void that consciousness moves through. But this is a projection. From the inside, there is no experience of absence because experience itself is what has vanished. Consciousness cannot witness its own removal. This is why the transition into anesthesia feels instantaneous in retrospect. One moment there is awareness, the next there is memory again. The interval in between leaves no trace, not because it was uneventful, but because there was no perspective from which events could be registered. The same illusion appears in deep, dreamless sleep. We say we were out cold, but this is only true from the outside. Internally, there is no sensation of being gone. There is no duration to recall. Time does not feel compressed. It simply does not exist as experience. This reveals a subtle but important point. Consciousness is not like a signal that fades until it reaches zero. It is more like a condition that either holds or does not. When the conditions fail, experience does not degrade into less vivid versions of itself. It stops. This is why reports of complete unconsciousness are always retrospective. They are inferences made after consciousness has returned. During the absence itself, there is nothing that could confirm or deny its existence. The myth of being turned off arises because language demands a subject. We speak as though someone was present during the gap waiting to return, but there was no one there. This misunderstanding has consequences. It encourages the idea that consciousness is a thing that can be lost and later found again. In reality, consciousness is not transported or stored. It is recreated each time the brain reaches the right configuration. Every awakening is a reconstruction. The self that opens its eyes in the morning feels continuous with the self that fell asleep the night before, but that continuity is not preserved through the night. It is rebuilt. Memory, identity, and perspective are reassembled, giving the impression of persistence. Anesthesia strips this illusion bare. It shows that the sense of an enduring observer is not a fundamental feature of reality. It is an emergent product of a functioning system. When the system cannot sustain itself, the observer does not wait in the dark. It disappears. This insight reframes what it means to lose consciousness. It is not an experience that happens to someone. It is the absence of someone to whom anything could happen. Understanding this distinction matters when interpreting reports from patients and when evaluating systems that cannot report at all. Behavior may cease. Responses may vanish. But the absence of response does not map cleanly onto the absence of experience. Sometimes consciousness is gone. Sometimes it is merely inaccessible. The next challenge is to tell the difference, and that challenge becomes most pressing in the grey zones where awareness may persist without the ability to speak, move, or remember. Places where consciousness has not vanished but is trapped. Not all losses of consciousness are complete. Some states exist in a narrow and unsettling middle ground, where awareness may be damaged, fragmented, or hidden rather than erased. These conditions challenge one of our deepest assumptions, that consciousness and responsiveness always rise and fall together. They do not. After severe brain injury, patients may enter a coma. In this state, eyes remain closed. Responses are minimal or absent, and sleep-wake cycles are disrupted. For a time, consciousness may truly be gone. But coma is often temporary. As the brain stabilizes, other conditions can emerge. One of the most misunderstood is the vegetative state. Here the body wakes up. Eyes open, sleep-wake cycles return. Reflexes operate, yet there is no reliable sign of awareness. No purposeful movement. No evidence that the world is being experienced rather than merely reacted to. From the outside, it looks like wakefulness without a mind. For many years, this was taken at face value. Lack of response was equated with lack of consciousness, but advances in brain imaging forced a reconsideration. Some patients diagnosed as vegetative show patterns of brain activity that resemble conscious processing when asked to imagine specific actions. They cannot move, they cannot speak, but their brains respond as if they understand. These patients are now described as having covert consciousness. Between coma and full awareness lies another category, the minimally conscious state. Here awareness flickers. Responses are inconsistent. A hand may move purposefully one day and not the next. A gaze may track a face briefly before drifting away. These fluctuations are not random. They reflect a fragile system struggling to sustain integration. The distinction between these states is not academic. It is ethical. If consciousness depends on network coordination rather than behavior alone, then silence is not proof of absence. A mind may persist without the ability to signal its presence. This realization has reshaped clinical practice. Doctors now use brain activity, not just outward behavior, to assess awareness. They look for signs of integration, responsiveness to meaning, and sustained patterns rather than reflexes. What emerges is a sobering picture. Consciousness can survive without memory. It can survive without speech. It can survive without voluntary movement. But it cannot survive without coordination. When integration falls below a critical threshold, experience dissolves. When it rises just enough, awareness may return faint and unstable. These boundary states reveal the true cost of consciousness. It is not guaranteed, it is not binary, and it is not always visible. They force a shift in perspective. Instead of asking whether someone appears conscious, the more precise question becomes, does the system still support a unified point of view? In the next step, that question becomes even sharper, because some minds remain fully conscious yet almost completely unable to act. And in those cases, the danger is not that consciousness is gone, it is that it is ignored. There are states in which consciousness is not broken but imprisoned. The mind is awake, experience continues, thoughts form, emotions arise. Yet the body offers no reliable way to signal any of it to the outside world. This condition is known as locked-in syndrome. Unlike coma or vegetative states, the damage here spares the systems that support awareness. Perception remains intact. Memory functions. The sense of self persists. What is lost is almost everything else. Movement is paralyzed. Speech is impossible. In many cases, even facial expression is gone. From the outside, the person appears unresponsive, inert, unreachable. From the inside, nothing could be further from the truth. Patients with locked-in syndrome often report full consciousness. They follow conversations. They experience frustration, fear, boredom, hope. They think, remember, and feel as vividly as they did before the injury. The only difference is that their mind has been cut off from its outputs. This distinction is crucial. It reveals that behavior is not consciousness. It also reveals that the absence of behavior is not its absence. For much of scientific history, awareness was inferred from action. If someone could respond, they were conscious. If they could not, they were assumed not to be. Locked-in syndrome breaks that assumption completely. Here integration is preserved. The networks that bind perception, memory, and selfhood remain functional. The point of view is intact. What fails is the ability to translate that point of view into movement. This failure creates one of the most ethically charged situations in medicine. If consciousness can persist without response, then silence cannot be taken as consent, indifference, or absence of experience. Decisions about care, pain, and quality of life must account for the possibility of an unseen mind. Technological advances have begun to narrow this gap. In some cases, patients can communicate through eye movements. In others, brain signals are used directly, allowing basic yes or no responses through patterns of activity alone. These breakthroughs confirm what locked-in patients have long insisted: they are still there. This condition also sharpens the scientific picture. It demonstrates that consciousness depends on internal integration, not on output. This system can sustain a rich inner life even when it cannot act on the world. Agency and awareness, though closely linked in daily life, are not the same thing. Locked-in syndrome is a reminder of how easily consciousness can be misjudged. It warns against equating visibility with existence. It cautions against assuming that what cannot speak cannot feel. And it prepares the ground for a broader conclusion. Sleep dreaming, anesthesia, coma, and locked-in states are not anomalies. They are stress tests. Each strips away a different component of awareness, revealing what is essential and what is not. In the next step, those lessons are drawn together, not to define consciousness once and for all, but to understand what these breakdowns collectively reveal about why consciousness exists in the first place. When sleep dreams, anesthesia, and neurological injury are placed side by side, a pattern emerges. Each state removes consciousness in a different way. Each exposes a different dependency. Together they outline what awareness truly requires. Sleep weakens consciousness without destroying it. The brain remains active, but coordination loosens. Integration becomes selective. Experience fragments or disappears not because the system is silent, but because it no longer binds itself into a single point of view. Dreaming preserves experience while abandoning constraint. Reality monitoring fades. Memory continuity collapses. The self dissolves. And yet awareness persists vivid and immersive, revealing that consciousness does not depend on accuracy, coherence, or even truth. Anesthesia shows the opposite extreme. Activity remains, but integration fails completely. The network that allows information to circulate collapses. No internal world can stabilize. Consciousness does not distort or fragment, it vanishes. Coma and related conditions demonstrate that recovery is not binary. Awareness can return unevenly. It can flicker. It can persist without behavior. It can survive without memory or movement as long as integration is partially preserved. These contrasts lead to a single conclusion. Consciousness is not tied to any one function. It is not perception alone. It is not memory alone. It is not selfhood language or agency in isolation. Consciousness emerges when multiple systems are coordinated into a unified process that can sustain a perspective over time. Break that coordination gradually and experience thins. Break it selectively and experience mutates. Break it completely and experience disappears. This explains why consciousness is so expensive. Maintaining integration across the brain requires constant energy communication and regulation. The system must continually resolve conflicts between internal predictions and external input. It must stabilize a self-model. It must bind moments into time. Sleep offers relief from this burden. Anesthesia enforces it. Injury disrupts it. Seen this way, consciousness is not the brain's default state. It is a special mode of operation that must be actively sustained. When the cost outweighs the benefit, the system lets go. This reframes a long-standing intuition. We tend to think of consciousness as something the brain has. In reality, it is something the brain does, and like any process, it can fail. The fragility of consciousness is not a flaw. It is a clue. It suggests that awareness evolved not to be constant, but to be useful, to appear when needed, to withdraw when it is not. In the next step, this insight is taken further. If consciousness is costly, conditional, and fragile, then its disappearance is not a bug, it is a feature, and understanding why the brain repeatedly allows consciousness to break may tell us why it exists at all. If consciousness were free to exist in any form at any time, it would be chaos. What sleep, dreams, and anesthesia collectively reveal is not just how consciousness breaks, but why it must be constrained in the first place. Awareness is powerful precisely because it is limited. Without boundaries, it becomes unstable, misleading, and often dangerous. In waking life, consciousness operates under strict rules. Sensory input anchors experience to the world. Memory binds moments into continuity. A self-model assigns ownership and responsibility. Reality monitoring filters imagination from perception. These constraints are not obstacles to awareness. They are what make awareness functional. Dreaming removes those constraints selectively. When reality monitoring is lost, imagination is treated as fact. When memory continuity collapses, time dissolves. When the self-model weakens, identity fragments. Experience remains vivid, but it no longer guides action reliably. It feels real, but it is no longer accountable to consequences. This is why dreams are absorbing but useless. They engage consciousness without allowing it to do what consciousness evolved to do: support adaptive behavior in a shared environment. Anesthesia goes further. By dismantling integration entirely, it removes not just constraint, but the very conditions under which experience can stabilize. Without a network capable of sustaining perspective, consciousness cannot exist at all. There is nothing to constrain and nothing to be constrained. These contrasts point to a central insight. Consciousness is not maximized by removing limits. It is stabilized by them. The waking mind is a negotiated state. It balances internal models against external evidence. It suppresses irrelevant signals. It enforces consistency over time. Each of these restrictions reduces freedom but increases reliability. Without them, awareness becomes unmoored. This has practical implications. Hallucinations, whether in dreams, psychosis, or extreme fatigue, arise when constraints weaken, but experience persists. The mind generates content without sufficient checks. What feels real is no longer tethered to what is shared. Normal consciousness avoids this fate by constantly testing itself. It asks whether perceptions agree with others. It checks whether memories align with evidence. It revises beliefs when predictions fail. These checks are costly. They require energy and coordination, but they prevent awareness from collapsing into solipsism. Sleep suspends these costs temporarily. Anesthesia abolishes them. Waking life reinstates them. Seen through this lens, consciousness is not a default state waiting to be turned on. It is a controlled achievement, a fragile equilibrium maintained by constraint. This explains why the brain allows consciousness to break every night, not because it is careless, but because sustaining awareness without purpose would be wasteful. Consciousness is deployed when it's needed and withdrawn when it's not. Understanding this reframes the entire discussion. The question is no longer why consciousness fails. The question is why it is ever sustained at all. The answer lies not in experience itself, but in what experience makes possible. And that brings the investigation to its final synthesis. At first glance, the fragility of consciousness seems like a design flaw. It breaks easily. It disappears regularly. It can be disrupted by chemicals, injury, exhaustion, or even a simple lack of coordination across the brain. But when viewed through an evolutionary lens, this fragility begins to look intentional. Consciousness is expensive. To sustain awareness, the brain must integrate information across vast networks. It must keep sensory input aligned with memory, prediction, emotion, and action. It must maintain a self-model that persists through time. All of this consumes energy. All of it requires constant regulation. From a biological perspective, this cost demands justification. Consciousness is not free. It must earn its place. The evidence suggests that awareness evolved not as a permanent state, but as a strategic one. It appears when flexible decision-making is required, when prediction matters, when uncertainty is high, when social interaction demands perspective-taking and empathy. When these demands recede, consciousness withdraws. Sleep is the clearest example. During rest, the need for real-time modeling of the world diminishes. The brain shifts priorities. Memory is reorganized. Metabolic balance is restored. Consciousness no longer necessary is allowed to dissolve. This is not a failure. It is efficiency. Anesthesia reveals the same principle in extreme form. When survival requires that pain, memory and awareness be eliminated temporarily, the brain's capacity for integration is forcibly disabled. Consciousness vanishes because it serves no function in that context. Even pathological states echo this logic. After injury, the brain may sacrifice awareness to preserve basic regulation. Integration is costly. When resources are limited, it may be the first process to fail and the last to return. Seen this way, consciousness is not the foundation of the mind. It is a peak state. It sits on top of many supporting systems. When those systems are compromised, awareness is not defended at all costs. It is relinquished. This reframes a common intuition. We tend to think consciousness is what makes us alive. Biology suggests the opposite. Life can persist without awareness. But awareness exists to serve life. Its fragility ensures that it does not dominate when it should not. A permanently conscious organism would be inefficient, distracted, and vulnerable. The ability to lose consciousness is as important as the ability to sustain it. Fragility in this sense is not weakness. It is selectivity. Consciousness appears only when its benefits outweigh its costs. It retreats when they do not. This balance explains why it's both powerful and precarious, and it points toward a deeper implication. If consciousness is fragile because it is specialized, then reproducing it artificially may be far more difficult than reproducing intelligence. Not because consciousness is mysterious, but because it is costly, conditional, and unnecessary for many forms of competence. That implication brings the discussion full circle. From sleep and dreams to anesthesia and injury, consciousness reveals itself not as a constant flame, but as a carefully rationed resource. Which raises one final question. If awareness is so easily withdrawn and so selectively deployed, what does that mean for systems that never need to withdraw it at all? The way consciousness breaks has an unexpected consequence. It changes how absence should be interpreted. Sleep anesthesia and neurological injury all show that consciousness does not merely scale down. It withdraws, it fragments, it disappears entirely when integration collapses. And crucially, when it disappears, there is nothing on the inside to register that loss. This insight matters beyond biology. In recent years, increasingly sophisticated artificial systems have begun to display behaviors once associated with conscious minds. They speak fluently, they reason, they explain themselves, they express concern, hesitation, even reflection. The temptation is understandable. If behavior looks right, we assume experience must follow, but the breakdowns of consciousness caution against that assumption. In biological systems, consciousness is costly and fragile because it depends on tightly coordinated processes that evolved under pressure. It appears selectively. It disappears when it is not needed. Its absence leaves no trace from the inside. Artificial systems, by contrast, do not sleep in this way. They do not dream. They do not require withdrawal to recover. They do not lose integration because they are tired, injured, or metabolically constrained. Their continuity is uninterrupted. This difference is not trivial. If consciousness is defined by fragile coordination under constraint, then systems that never need to suspend operation may lack one of its core signatures. They can simulate awareness without ever needing to relinquish it. They can perform without vulnerability. This does not prove that artificial consciousness is impossible, but it does shift the burden of evidence. Intelligence alone is insufficient. Performance alone is insufficient. Narrative alone is insufficient. Consciousness, as revealed by its breakdowns, is not about what a system can produce, but about what it must sometimes lose. Ethically, this distinction matters. If we mistake fluency for feeling, we risk extending moral concern where none is required. At the same time, we risk overlooking real experience where behavior is absent or minimal, as in locked-in states or disorders of consciousness. The lesson cuts both ways. Do not assume consciousness where there is smooth performance. Do not deny consciousness where there is silence. The science of broken consciousness teaches restraint. It demands humility and attribution, and it reminds us that awareness is not announced by competence, but inferred from fragility. As this investigation comes to a close, one idea stands out. Consciousness is not defined by what it does at its strongest moments. It is revealed most clearly by how it fails, and in that failure it leaves behind the most reliable clues to its nature. The final step is not to answer the question definitively. It is to recognize what kind of question it truly is. Every night, consciousness does something remarkable. It releases the world. There is no ceremony, no sensation of departure, no awareness of crossing a threshold. One moment experience is present anchored continuous, the next it is simply gone, not replaced by darkness, not suspended in waiting, just absent, and in the morning it returns. This daily disappearance feels trivial because it leaves no memory behind, but that absence is precisely what makes it revealing. Consciousness does not drift into nothingness. It is dismantled quietly and efficiently when the conditions that sustain it are no longer met. Sleep shows us this gently. Dreams show us what remains when constraints are lifted. Anesthesia shows us what happens when integration collapses entirely. Together they expose a truth that is easy to miss while awake. Consciousness is not a constant background of existence. It is an active achievement, a temporary organization of matter that must be maintained moment by moment across fragile networks. It does not persist because it wants to. It persists because it is useful. When usefulness fades, awareness is allowed to withdraw. Life continues. The body regulates itself. The brain repairs, reorganizes, and recalibrates. Consciousness is spared the effort of witnessing processes it does not need to guide. This does not diminish its significance. It clarifies it. Consciousness exists not to observe the universe, but to navigate it, to model what matters, to predict outcomes, to choose among possibilities when uncertainty demands flexibility. When none of that is required, the system lets go. This perspective reframes a deep intuition. We often imagine that consciousness is what we are. In reality, it is something we enter. Each morning, awareness is reconstructed. Memory rebends. The self reforms. The world regains its authority. And the illusion of uninterrupted existence resumes. But it is an illusion worth having, because without it there would be no perspective, no meaning, no experience at all. Sleep dreams and anesthesia do not threaten consciousness. They define its boundaries. They show us where it holds, where it bends, and where it breaks. And in doing so, they answer the question that began this journey. Consciousness does not disappear when we fall asleep. It lets go of the world. And when it returns, it does so not because it was waiting in the dark, but because the conditions that make experience possible have quietly come together once again. That is not a mystery to be solved. It is a process to be understood, and one we live through every night without ever noticing.